What's up, RubyConf? Kevin Lesht here, and I wanted to bring you into the kitchen for this talk titled Automation Engineering with Serverless Compute. Or how I keep my omelette blog up to date. Yes, as some of you out there may know, I eat quite a few omelets. And to document those creations, I take a picture to really capture the moment. And I post those pictures to my omelette blog, 5minutesinaflip.com. Only I haven't been good about keeping the blog up to date. My last post was in 2019. I've still been eating the omelets, and I've still been taking the pictures, but I haven't been posting. And I've found that it's really the process of bringing these photos online that's holding me back. It's just a lot to manage. See, after I have my omelet photo, there's this whole getting it online part. The blog is managed by Tumblr, and so I have to open their app, select the photo, and post. It's a whole thing. A thing that some might say is easy, but to them, I would say not easy enough. I wanted my user experience to be I take a photo like I would of anything else, and that's it. End of the line. If it's an omelet, it makes it onto the omelet blog. That sounds easy. So I started thinking, what the heck would that even look like? This is the future to me, and I have no idea how to get there. So let's backpedal a bit and see if we can lay down some tracks. Assuming I have a photo, if it is an omelet, I want it uploaded to the omelet blog. If it's not an omelet, I don't want it on the blog. Sorry, pup. Don't worry, she'll be back later. But spiking this out does already identify a step in our process. We're going to need to figure out how we can parse an image and detect if it's an omelet or something else. And then, after that, if the photo we're looking at is of an omelet, it can be patched to the blog. So when I take a photo, we parse and we patch. Parse and patch. Parsley patch? Yes, we have a name and a logo. Credit to my friend Tom McHenry on the logo there. How great is that? There's a few of those coming up, and he crushed it on all of them. So thank you, Tom. Anyways, now we can really get to work on this project. Only thing that was stopping us right there, the logo. So in order to build a service that can parse my photos, I suppose that we're first going to need access to those photos. I'm using my phone as my camera, so my first thought here is some kind of mobile app that could hook into my camera events and on photo taken, kick off the process. Whatever that later process might be. But wait, hang on. I already have an app that does just that. Google Photos is configured to automatically sync my pictures up to the cloud. So maybe there's something to leverage there. Maybe a Google Photos API that I could hit. A little research, and look at that, a REST API. That's interesting. And it looks like they do have an endpoint for returning the contents of a library. This might be just what we're looking for. But wait, hang on. OAuth. This may actually be tricky. Let's talk about OAuth. See, when making an API request, some endpoints are going to need authorization. We wouldn't want just anyone looking into my Google Photos. I mean, who knows what they might find in there. And so OAuth is a protocol for signing API requests to essentially say that you're authorized to access what you're asking for. The problem here is that everything I know about OAuth with Google is that it's usually web-based. You log into your account, and the application initiating the request is then granted an access token. That token can then be used to sign requests for access to the user's content. Well, that's just not going to work here. The whole point of this project is easy. It's automation. I can't be bothered to go to a website and log in. And shoot, this also raises an interesting point. If I'm not planning on running this stuff through a website, where am I planning to run this? Well, I've been hearing a lot about this serverless technology stuff, and I have been wanting to play around with it. Maybe there could be something here. See, with a serverless function, the provider manages all of the infrastructure. Hardware, the operating system, hosting, all of that stuff is abstracted away. And your code is all you focus on. So in something like an AWS Lambda, you can write a script, wire it up to be called, and run things all without being at the controls. I like this. It's also in the talk title, so let's see where it takes us. Now, back to that OAuth piece. We still need to figure out how to OAuth when there is no browser. And it was pretty clear that this was not going to be resolved by a quick search. And I hit a brick wall. We all hit them, and sometimes they look like this, or sometimes they might look like this. But no matter how they choose to present themselves, they come as an obstacle. Some resistance that we need to fight through to get to where we want to be. Now, I have hit so many brick walls in my career that I've studied the concept. And one framing that really stuck with me comes from Randy Pausch, a famed Carnegie Mellon professor. In his famous last lecture, he presents them as being there for a reason. They're to let us prove how badly we want things. It would have been easy to quit right here. Nothing was working, and everything I tried was coming up short. But I really wanted to automate my omelette blog, and so I kept at it. And sometimes all it takes is a little persistence and a different approach. In an article by Martin Fowler, he explains that you can set up a one-time Webflow to issue what's called a refresh token. And this refresh token can then be stored and used to call out to Google whenever you want for an OAuth token. That OAuth token is all we need to sign our requests and to access Google Photos. By stepping through this flow one time, we can store our refresh token in an environment variable to later access from our Lambda. Then, anytime we kick off our service, we use our refresh token to authenticate with Google. From there, we can send a signed request to the Google Photos library endpoint to return my photos. So with access to a photo in hand, the next step in the system is to parse it and see if we have an omelet. This part I can handle. Have you heard of a site called Caption Caddy? How often have you been about to post a photo to social media only to falter at the last minute without a caption? Caption Caddy was a project I developed to solve just that problem. User uploads a photo. See? Told you she'd be back. AWS Recognition runs object detection and returns suggestions on what it thinks is in that photo. And from there, we return a high-quality caption from my database. So, drawing from my past work here, I'm thinking that we leverage AWS Recognition. This service takes a photo and with deep learning technology identifies objects to provide back a list of labels and confidence scores. So let's test this out. And in order to test, we're going to need data. So let's make an omelet. First, the pan. Make sure you have a good one and fire that thing up. Throw in some butter, like a lot of butter, and it's time for the eggs. 4 in, 3 yolks out. Some whisking. In the pan, a flip, and omelet. Throw down an avocado, dig into those right now, and we're ready to go. Taking our photo, we can run it through Recognition and wait. Well, some of these are close, and I guess some of these are technically correct, but no, this is not going to work for us. See, after some research, it turns out that the default recognition interface leverages pre-trained models. And for a lot of cases, this is great. With a pre-trained model, you can really recognize a lot. A huge span of objects and scenes and activities are all easily detected. And you don't have to deal with any of the setup needed for a custom model. You don't have to gather training data, you don't have to ready your model for production, or anything in between. But if you're trying to detect something that's a bit obscure, you might need to go custom. and train a model specifically designed towards recognizing what you're looking for. Now, omelets, not that obscure, at least to me, but we need precision here. We can't risk missing a photo and letting our fans down. So it's time to custom train. First, we need to create our data set, a collection of images with the objects that we want to detect. Luckily, I've got a few of those. Now, for a good data set, we want our target objects to be presented in a bunch of different ways. Different backgrounds, different compositions, different framing. The more variability we can provide will better the chances of our model being able to detect an omelet, no matter its presentation. Because let's be real, I'm not Jacques Pepin here, and I can't nail it every time. Ugh. So, with a good set of omelet photos in hand, we upload them to Rekognition. And it's time to label. At this step, we go through each image and classify what we're seeing. Each of our photos is going to have an omelet, so we can apply that label across the board. But then we also might want to call out other things, like avocados or toast, or sometimes chili. No joke, great omelet pairing right there. Not even kidding. All of the labels we can provide are helpful. The work can be a little tedious at times, but these definitions are critical during training to help our model learn to recall the objects that we're looking for. Once our data set is labeled, it's time to train. To do this, we want to put together a test set of data. Within this set, we want some images that have our targets and some that don't. As the model trains, it'll process our data and leverage its learnings against the test set, stepping over each test image to validate if our objects are present and honing its accuracy. Once training is complete, we now have access to a machine learning model custom trained to fit our needs. We can spin this up, and taking our photo and running it through our now custom model, we get our labels back and now know that this photo is an omelet, because it wasn't apparent before, at least not programmatically. And I suppose that takes us to the patching end of the service. Once we know that we have an omelet, it's time to upload the photo to the blog. Well, wait a minute. Where are we even sending these images? Up until now, the idea was that all of this work we've been describing would live inside of a serverless Lambda function. And well, the implication of serverless is that there is no server. I'm not really going to be able to store these photos in there. You can temporarily store files within a Lambda, but as soon as your function invocation returns, you lose your reference to those files. Well, I know this is going to be a static site just showcasing my omelet photos, and I do have a few of those floating around out there. And these are all just hosted on S3. Here, you can configure a bucket for static website hosting, and you can also create, update, or delete your files programmatically through the AWS SDK. Once we know that we have an omelet, we can upload the photo to our S3 bucket, and all from within our Lambda. So let's go with it. And while we're at it, let's rebrand. The new and improved 5minutesinaflip.com. Okay, so we have a photo, and once we know that it's an omelet, we post it to an S3 bucket that sits behind the site. And after that, well, you know what? Shoot, site's still going to be the same. See, even though we've added our photo to the bucket, our HTML hasn't been updated to include the new post. We need to rebuild the site. This was a tough one, and where I really had to take a step back. See, the process diagrammed out so far was to authenticate with Google, fetch a photo from my Google Photos library, parse it for an omelet, if an omelet, patch it to the S3 bucket, and then rebuild the site. And this would probably be okay if we were dealing with just one photo. But in reality, there are times where I take more than my daily omelet picture. It's rare, but it happens. We can't always assume that the last photo in my library will be an omelet. That's why we've built the whole parsing end of this service. And so when we request my library contents, we're really going to want to grab all of the photos taken since the blog was last updated. Then we process that whole batch for omelettes. And only once we've made it through the entire collection of photos and have posted any omelettes to our bucket, can we rebuild the site. So how do we do that? How do we reconfigure this process around the idea of a batch of photos? Well, going about things procedurally might be an option. We could collect all of the photos taken since the blog was last updated, and one by one, parse them for omelettes, patching any that hit to the blog's S3 bucket. Then, once we've processed all of our photos, we can run some code to rebuild the site. Here, we hit our S3 bucket and collect the keys for all of our photos, with the keys we collected representing file names and our site design being that of just photos with headings. We have all the information we need to put things together. We break the keys down into batches so that we can paginate. Gotta have that. And for each batch, we step over each item, plugging its key into an image tag, and the base name from that key into a heading. Apply this over all of our items, slap our logo on there, link up our pages, and we've got our site. We store our pages as temp files within the Lambda, and once all are ready to go, we upload our files to the S3 bucket. Once that's done, we log the time of build, so that next time the service runs, we can read in that timestamp to use in our Google Photos query so that we're only pulling in the pictures taken since our last update was published. But where do we store that timestamp? With Lambdas not having any reference to their last invocation, we're going to need to pull in another service. Some place of persistent storage where we can hold on to the time of last run. DynamoDB is another AWS service that might solve this problem. Here, we can store keys with values with easy access from within our Lambda. After our site builds, we can write the timestamp of the last item in the batch, and then read that back when we kick off our next job, so that we're only picking up new photos when we query my library. This might just work, but looking things over, something didn't feel quite right. Taking a closer look at our running the parsing and patching of photos procedurally, one photo being processed doesn't depend on another, and so there isn't any reason why we need to wait on one photo before moving on to the next and waiting again and again. Pulling at me was this idea of doing things concurrently, of processing all of our photos at the same time. We would have to figure that out though, and we're so close right now to achieving what we want. Reeling things in and being on our way, nobody would fault us for it. We have been on a journey here, and this pursuit of easy may have gotten away from us by just a little bit. But as I was close to wrapping things up, something happened. I wanted the challenge of the harder path. I wanted the brick wall. Thinking back to Randy Posh, he had framed those brick walls as being there for a reason, to prove how badly we want something. But what I had found was that those brick walls, they offer something in themselves. They can be frustrating and something you want to power through as quickly as you can. But rather than smashing through a brick wall and never looking back at the bricks, by slowing down and taking things apart, piece by piece, you learn about how it was built up. It becomes an exercise in practicing your craft and an enjoyable experience. In the future, you begin to recognize similar walls and can move through them more easily. Once you recognize them for what they are, a certain calmness takes over. You start to want more. You begin to seek out those difficult challenges. That's what I had recognized here. There was a real opportunity to try something new, to learn something. So let's dig in. In order to process all of our photos at the same time, rather than keep one Lambda open and evaluate each photo one by one, we can move the parsing and patching into its own service. And if we really want to have fun, how about this? DynamoDB offers what they call an event stream. The event stream is a flow of information about the changes to the items in your table. It captures things like inserts, updates, and deletes. Even better, we can easily hook up lambdas to fire off at any one of these events. When we query Google Photos, we could insert each photo into our database as its own record and wire up a lambda to invoke on each insert. Our lambda will receive the photo item as a payload and can handle the parsing and patching of that photo before exiting out. Now we're really cooking. We have the concurrency we want. But this does throw a curve at our rebuild step. See, under a procedural approach, with each photo being processed one after another, we can confidently say that once the last photo has been evaluated, all before it have too. This made for a nice signal towards when to rebuild. But with all of our photos now running concurrently, they'll be completing independent of another, and we won't have a marker telling us we're clear to rebuild. We're going to need to keep track of when a job finishes, and then when all jobs have finished, we'll know that our photos have been handled and we're safe to rebuild the site. So let's think on that. We could count the number of items in a batch and store that number in our database. Then, for each item we process, we increment a counter. After each job, we can check to see if our counts match. And once they do, we rebuild the site. Only, what happens if we hit a race condition? We could run into a spot where two jobs kick off at the same time. Both would read in the same count number, and they'd each write back the same value. Our counts would never match, and we'd never rebuild the site. So that won't work. Well, we're already planning on managing our photos as items within our database. So how about adding an isProcess field onto each record? This attribute could start as false, and as a partially patched job closes, we could flip it to true and query the batch to see if all have finished. When that's the case, we rebuild the site. But nope. Just the effect of jobs running at the same time opens this approach up to a race condition too. This was starting to look more difficult than I had bargained for, and it was about this time that I was starting to question what I had gotten myself into. I couldn't manage a counter, I couldn't query for all the records being processed, I couldn't close the job. And then a thought, I just needed some help. So I called up a friend, Dave Junta, VP of Engineering at Home Chef, great guy, inquisitive guy, asks a lot of questions. But after some explaining and a conversation, an idea, another lambda. See, before, the plan was to check for all records being processed after each individual parsing patch job as a callback. And with concurrency, that opened the risk of transactions landing at the same time and not getting the right data to close out the batch. But with a totally separate thread, we could query for all of the records in our table on some interval, independently of the jobs themselves, and just keep listening until that process field comes back as true across all of the items in our batch. Once we hear back, we rebuild the site. Yes, this might just work. End to end. Every day, a job scheduler kicks off our first lambda. We query DynamoDB for the created at timestamp off of the last photo record inserted. We get an OAuth token from Google to use in querying Google Photos to retrieve all of the photos that were taken after our timestamp. Each photo is written to DynamoDB, and once all photos are written, our site generator kicks off and begins listening for all records to be processed. Inserting into DynamoDB kicks off a partially patched lambda for each photo record. The partially patched lambda sends its photo through recognition to receive back labels. If omelette is detected, the photo is patched to the 5 minutes in a flip best 3 bucket. The record's isProcess value is updated to true, and when all records have been processed, the site generator rebuilds the omelette blog. Holy cow, we've made it. Easy, right? Now, on the topic of easy, I set out on this project because I wanted easy. It just turned out that easy wasn't easily achieved. I may have gotten a little carried away and designed an overly complex system, and all of this probably could have been done a dozen different ways. But sometimes you have to dev out. I learned a ton following the threads of this project, and most importantly, you know what wasn't complex? Breaking through those brick walls. In one case, I just reset and approached the problem from a different angle. In another, I drew from a past project. I broke down a problem into smaller parts. I asked a friend for help. I came into this project viewing brick walls as intimidating things, as obstacles. But they're not obstacles. They're opportunities. They take time and patience and sometimes a little help to break through. But they're opportunities to connect and to learn. And you will break through. And once you do, you can apply your work to all sorts of things, which is great news because with what I've learned here, I can get started on my next project. I don't know if you've heard, but I'm starting to make pizzas too. Yes, Kevin's Pizza Pies. We'll save that one for next time, but I'm sure it's going to come with its brick walls too. And taking what I've learned here, maybe there'll be an easier approach. But if there's something more out there, if there's an opportunity, I'm going to take it, and you should too. And when you get hit with one of those brick walls, take a step back and smile, because you've just found some fun. Thank you. Thank you for attending. Thank you to our organizers, and thank you to our sponsors. The slides for this talk can be found at kevinlesht.com/RubyConf2020. If you're interested in checking out the omelette blog, that's at 5minutesandaflip.com. If you have any questions or compliments for me, you can find me on Twitter at kevinlesht. If you're interested in more content like this, I host the Day as a Dev podcast, where I think the omelette blog has come up on every episode so far. And if you'd like to check out any of my other projects, you can keep up with those at kevinlesht.com. Thank you.